Look at all this cool 3D printed stuff. These prototypes couldn't have been done without certain technologies. This is SLS technology. Al from 3DChimera is here to talk to us about some of these technologies and what's possible today. And we got a couple of trick questions. We're gonna throw them at him, and just thank you so much, Al, for making the trip and being here with us, man.
Yeah, absolutely. It's great to be here. We've been working together for years.
Yep.
I think before you even started Lime, so I love to connect and see how we can work together, chat a little bit more. Should be fun.
I love it, dude. So we're enjoying it's 5 o'clock somewhere, and we're gonna enjoy a nice wild turkey.
Yeah, very good.
All right, so I got a couple questions prepared here, and I guess we can kind of just keep it casual and just kind of keep off cuff.
Sure.
But I wanted to have some structure, a couple things that I wanted to touch on with you, because there's a lot of very important questions about 3D printing and additive for manufacturing.
Yeah,
right?
absolutely.
Yeah. All right, so are you ready?
Let's go, man. Load them up.
Question number 1. Alex, what are the biggest challenges of additive technology for manufacturing?
Okay. Well, what I would say really with any kind of additive technology, whether it's for manufacturing, prototypes, toys, whatever the case might be, the biggest challenge is understanding the parameters that make something successful in 3D printing. So we call that, design for additive manufacturing, or DFAM. And, we work with guys like you that work a lot with 3D printing. Of course, it's no problem, right? You understand all the rules, and really it's not that tricky, but it's a completely different set of rules from injection molding or CNC or sheet metal or whatever the case might be. And I think that's one of the biggest challenges is people bring us designs or come up with ideas that are based and optimized for another technology, and then they try to make it work here.
I think one of the tricky things about 3D printing and preparing parts for 3D printing that it really, okay, so let's, even in the 3D printing world where we have, FDM and SLA and SLS, right, as are the main ones, and poly, all of them are going to have the specification, like, certain things that make them come out better. So what works well on one technology will not work well on another technology, right? And that's actually one of the cool things about SLS technology, that you don't have to worry so much about having to put it in a certain position so that it comes out without so much scarring from the support, which you'll get with some of the technologies like this. Can you do a close up? Can you put that close up? That structure right there has to be removed by hand, and then there's going to leave a couple little points. So depending on what you're doing with that prototype, you might have to sand it down, and then you start getting into adding manpower or hours, right? Labor to. So now something that could cost a couple dollars now needs to cost $10, $20.
Absolutely.
Or whatever, right?
Yeah. I think that's one of the things. So each of the technologies have their own strengths and weaknesses, right? Yeah. So when we look at something like, a resin print like this guy, right? One advantage is you get incredibly fine details. It prints pretty quick. You get nice smooth surface because we're starting with a liquid, right? So it's like that magic, like I don't know, that dude from the Terminator that like melts and comes out of nothing. It's very similar to that, right? But at the same time, you've got the supports. That's one thing.
Yep.
The other thing is that this is a UV cured process, right? So we're using a UV cure resin. So we're putting the resin in. We're using light to cure the part, whether it's an LCD screen or a laser.
Yep.
Right. And that's fine and dandy when you print your part. But then what happens when you go sit that out in the sun? It continues to cure. Right, it continues to change over time, so its properties change. So
it can become brittle, from what I've seen a lot of times.
Yeah, brittle or other properties. Maybe it was a flexible part and it becomes less flexible over time, or maybe it's a rigid part and it becomes more flexible, right? Because the properties are going to change based on the resin. So that's the weakness of this, right? So if you need fine, beautiful details, maybe a show model, it's great. Sometimes for engineering grade parts it can work, but it really, really depends. And SLS, for example, that's a powder-based process. No support material. This is such a cool example. This is 50 parts. These are all printed at the exact same time in this cage, just like this.
That's so cool, man. That's amazing, man.
Yeah, and it's a real game changer for production, right?
Yeah, because basically you just have to vacuum off the old parts or whatever, reuse that powder.
Exactly.
And then, man, like, can you pull anything out of that?
No, this cage is totally sealed.
Oh, man.
This is what the part looks like afterwards. So it's basically like a spacer part that I guess went on to like a CNC type machine. So we actually had a guy come to our shop. He actually has like a YouTube thing. His name is Dr. D-Flow. And he came by and he actually came to us totally not for this application, he brought that part to us and wanted us to design a soft jaw that we 3D printed out of carbon fiber nylon, which is like a functional part.
Yeah.
While he was there, we were looking at the part and we were like, dude, how about we just 3D print the part?
Yeah.
Right.
Yeah,
So he needed a soft jaw because he needed to modify the part. So we said, well, why don't we just print the exact part you need? And we were able to print 50 of them, like while he was in town.
Wow.
So it was pretty cool and pretty straightforward for us. But even for him, someone who's super experienced in additive, he was like, oh, geez. And, you know, he doesn't work with SLS. He builds like big FDM machines, right? And that's like the technology that built that skateboard. Awesome. Super functional. That skateboard, almost everything on that is 3D printed except the hardware. That deck is 3D printed. Those wheels, those hubs, everything on that is 3D printed. But at the same time, you know, that requires a huge machine. It's quite slow.
How many hours do you think to print all these parts?
That's probably 150 hours of 3D printing, right? So from a commercial perspective, that doesn't make a ton of sense.
Right.
But it makes great sense for a prototype or, you know, to kind of, we built that to show off this new material that had been built there.
Yeah.
So you can do a lot of different things with that technology as well. So each have strengths and weaknesses.
Yeah. And
they're not super easy to know. And I think that's one of the big challenges that people run into is that there's a lot of disparate information out there. And I think with the rise of like the consumer level 3D printers, it's both like it's like a beautiful thing because the technology has become more affordable. And in a lot of ways, it's really challenging because there's a lot of misinformation out there. There's people that have poorly tuned machines that then develop a habit that works with that machine, then try to tell everybody that they're right because it works on their machine, but it doesn't translate to any others. And you start to kind of go down this crazy spiral, right? And so
repeatability gets more difficult as, you know, as you have less help keeping machines maintained also and calibrated.
Exactly. Yeah, that's what it is. I mean, at the right hands, I think probably any 3D printer can be great.
Yeah.
Right. But the trade-off is time, right? So that's where people a lot of times get stuck. You know, they start with additive, especially in a business setting. Maybe they go to Amazon and they buy some type of 3D printer off there.
Yeah.
What they don't know is that they bought was a science project. They bought a project that requires like constant tuning and tweaking, and it's awesome if you're a hobbyist. It's terrible if you're trying to run a business.
Man, and I feel so bad for people that don't know what they're getting into. They buy a $300, $500, even $1,000 3D printer. If you don't know how to maintain this machine, and if you don't have the patience to watch how it works and see why it's not working right or whatever, see if it's bumping into something, you have to really observe and know the machinery, because guess what? There's nobody for you to call to come fix your machine. So if you're buying a $300 machine, you're also the mechanic of that machine.
Exactly.
And it's hard because like people come to me and they're like, hey, please fix my machine. I've already spent 100 hours messing with this machine. And it's like, all right, well, it's a $300 machine. I charge $150 to look at it. You know what I'm saying? So like, is it worth it? It's not worth it. I don't know. That's up to the person.
Yeah.
You know? But,
yeah, I think at the end of the day, that's one of those tricky things, right? So, the dude's spending 100 hours. He spent way more than the machine was worth, right? Just tinkering with this guy.
Yeah.
Right. So he thought he was going in saving money up front.
Yeah.
When if he would have started with an industrial 3D printer, that's not to say they don't break, but he would have had a professional company there to assist. I think we ran into something like that. You've got a 10-year-old machine here.
Yep.
Just the other day, you had a problem, right?
Yep.
I think a motor broke or something, making a weird sound.
Yep.
You called me, right? We look at it on WhatsApp, and instantly I was like, "Oh, that's the shaft on the y-axis, right?"
Yep.
And so we replaced the motor, right? We sent that over with your dude the next day, and your machine's back up and running, right?
Yep. It was a nice and easy fix. We were back up and running the same day or the next day.
Yeah.
So if I had to go hunt after what's wrong with this problem, then you start getting into, well, you fix this part because you think it's this part, then you fix the other part. Just like a car, if you don't know what you're doing, you're going to be just changing a bunch of stuff.
Exactly.
That costs money and time and downtime for the machine, especially if you need it for a business. So I used to have 6 Anycubic chirons. Oh my God.
Didn't like these guys, huh?
No, John, I want you to do some B-roll and show my people where the chirons currently live in my office.
Oh yeah, where is it?
In the storage, on the top of whatever, in a box. There's 6 of them that we just sit them up there taking up space.
Yeah.
So because when I was growing my business, I couldn't have 10 of those machines. I had to get one of those and then try to expand other ways. You know what I'm saying? And it worked for a little bit.
Yeah.
Especially because I'm mechanically inclined and I can fix the machines, it's easy. But I don't advise it. Like if you want your kid to get like hey, my kid thinks 3D printing is cool, and then you get him like this machine that's gonna have all these problems and it's gonna ruin his experience. And that actually messes it up for people that are excited to come into this field, and then they're like, womp womp.
Yeah, that's very real. I think you really hit it on the head. For someone who's mechanically inclined and also has unlimited time, it's super fun. It's like you can make any 3D printer work. It's like those dudes that are like building kit cars or like model trains. I mean,
it's a good hobby.
It's totally a hobby.
They will learn from it.
Yeah, there's value there, but like they have to know that's what they're buying into, right? And I think there's also like just a ton of misinformation out there about what printers can do and what they can't do. And so, people end up buying a 3D printer, I think, often thinking like, hey, I'm going to 3D print a microphone. Like, dude, I mean, even if you have the design skill, even if you have the materials, like there's electronics in there, there's wiring, there's all sorts of stuff that goes into that. It's not just that. Or even if it was purely mechanical, there's going to be screws and springs and hardware
and the 3D modeling to create the part that you need.
Exactly. So there's a lot of pieces of the puzzle.
Not always worth it.
Exactly. Yeah, I mean, we found that we built our business as purely B2B. It always has been. It continues to be so. We work with businesses like yours. I mean, we worked with you right when you started.
Yeah. That was in 2015, by the way.
There you go.
Been about 7 years, almost 8. Well, whatever, 7 years.
Who knows, man? It's like 2020 forever now.
Yeah,
we're way out there now. But dude. I mean, it's crazy. We work with guys like you, right? And the same. Like you could be on my call texting me and like 5 seconds later, it's, a lead engineer at Apple, right? Or I'm talking to someone at Adidas, or I'm talking to another small business that, nobody's ever heard of, right? For us, it doesn't make a difference, right? Like equipment is equipment and engineering problems are engineering problems. And so we look at the problem, we look at the equipment, and we try and help find the best solution for our customers.
Yeah. I got a really hard question for you, man.
All right, let me hear it. What do you got?
I mean, you've seen every friggin' 3D printer in the market right now.
Yeah, that's for sure.
What's non-biased opinion?
Yeah.
Because you sell certain equipment.
Yeah, I sell a variety, yeah.
What is the best 3D printer available for the average consumer right now?
Oh, for the average consumer. See, I think that's a tricky one, right? Because I don't really play in like the consumer space. I think if you're in the consumer space, you fundamentally go down a split path.
So let's talk semi-professional then.
All right. I think if you're at like a pro level, I think really the best way to think of it is like, if you were to ask me what's the best technology out there, I would fundamentally say powder bed fusion, right? Okay. So that's going to be SLS or MJF. Those are going to be the main two things. And the reason I say that is that it gives you incredibly fine detail. It gives you super strong parts. You can print a huge volume of parts like this, or you can print individual parts, and it allows you to truly scale with additive, right? So you can build a true business off of it. And like this is a MJF part. This is on about a $250,000 machine. This part, right, is printed on our Syntratech machine. This is like maybe like a $50,000 machine. You could produce a part at this scale on our Syntratech kit, which is like a $6,000 machine. But that's about as low as an SLS 3D printer goes. So I think
tell me more about that kit, man.
Yeah. So if I was a business and I had parts where I needed functional pieces and they were physically small, which, we talked about the different rules of additive, right? If you're printing SLS, you want to be thinking a large volume of small parts. You never want to be thinking a few big parts.
What's the volume? What's the build size?
So it's all relative, but the kit is like 3.5 by 3.5 by 3.5 inches.
Ooh.
So very small cube, right? But remember, we print in 3D, right? So even this guy, which is printing 50 parts in this space, we could probably fit 15, 20 of them in a single print. Now that's a heck of a lot, right? So 15 or 20 of these on an FDM 3D printer requires like a 15-inch bed, right? But because we are taking advantage of the full three-dimensional space, you get this crazy advantage. That's why
stacking.
The stacking.
Yeah.
That's why I love SLS so much. So if I was talking to a business owner, which I often do, or saying, what should I start with? Always I recommend powder bed fusion. And that's, of course, we like the Syntratech brand, but really any powder bed fusion. There are lots of other brands out there. I'd say that's by far my favorite. Mostly, though, people don't go that direction. Normally, people are going to either go resin-based or they're going to go FDM-based.
Why?
Well, I think those are the two oldest technologies in 3D printing, and they're also the two most popular. So
resin was probably the first one, right? I believe.
yeah, I think resin was probably the first. Interestingly, like all three of the technologies kind of came out at the same time, but it was only like within the last 5 years that SLS 3D printing even became remotely affordable. Like even the cheap SLS 3D printers 10 years ago were $250,000 or more.
Mm-hmm.
Today, the cheapest one is that $6,000 machine,
Mm-hmm.
right? So they're coming down, but like that machine has been the same price for like 6 or 7 years. I don't see it coming down. We don't see a lot of competitors coming into that space right now.
So that kit, basically, what you have to assemble it.
Oh yeah, this thing is a beast too. It's not like when you go.
How many hours you think?
It's about 30 hours of labor,
Okay, that's not
like
too
straight
bad.
labor.
All right, so we've got a week assembly time, a week of assembly time or so.
Yeah,
And then what about starting it? Is there a lot of calibration, or
no,
is it?
That's another cool thing about SLS, right? So you build the machine, you get it calibrated. So you're basically setting up your temperature zones on that machine. So what that does is it basically you start with a powder of plastic, and you heat it up with lights to get it just about to the melt temperature, and then you use a laser to trace the shape, and it puts just a little bit of energy to cause it to sinter or melt, selectively sinter. Selective laser sintering. That's where the SLS comes from.
So what? There's a first a passive light, and then a laser.
It passes the powder over. Then these light bulbs kind of flash in there, which is what creating the heat. There's also ambient heat through other heater cells and whatever. And then you're using this laser to trace the shape of the part one layer at a time. Then it puts the powder over, and it continues going. So that particular technology, it's a bit of a commitment up front to build it, but then it works great. And it can work good in an industrial setting. The bigger machines come ready to go out of the box. So usually when I'm starting with a business owner, that's what I'd recommend. But back to your question, if I were a consumer or maybe just kind of starting a business out, maybe I didn't know about that or don't have that kind of budget. In the FDM world, what I hear a lot of people who have really good success, and I actually see in repeatable business settings, are the Prusa 3D printers. Mm-hmm. We don't sell those, but those are FDM style 3D printers. I think they're a couple $1,000s each. You can buy machines for a fraction of that price that are about the same size, but it's about that reliability. Mm-hmm. So I regularly meet customers that might have 5, 10, 15, 20 of those machines, and they're relatively happy with them. Mm-hmm. And then I think on the resin side, it's a little bit of a mixed bag because resin 3D printers are actually very similar. It's actually a very easy technology to build a machine for. There's very few moving parts. You're having issues?
No, I'm not, but I've seen the technology change because I've had the first formlabs.
Yeah.
I've bought the Anycubic, like DLP machines.
Yeah.
I'll tell you what, all the cheap machinery I sold off to somebody else, or it's sitting in a graveyard right now.
Yeah, yeah.
Like, I don't have time. I don't have time for it, man. Like,
well, that's because you've evolved past that starting stage, right? So now you're relying on these machines to make you profit, which means they got to be there.
Yeah, yeah.
Right, and so I think that's part of it. But if you're kind of starting out, I think the resin side, they're all kind of cut from the same cloth. Mm-hmm. As you start to step up, what you see in any 3D printer are really more high quality parts, right? So you'll see screens that are going to last longer, lasers that don't wear out as quickly. Mm-hmm. You're also going to see better quality motors, better quality, belts. You're going to see better quality pulleys and bearings and, hardware components. So that's really the difference. I mean, mechanically, they all have to do the same thing, right? And when you get one of the consumer level 3D printers, if you don't print a lot or when they're really new, they tend to be great. And then what ends up happening is pretty quickly, those belts stretch, that laser starts to lose intensity, the screen pixels start to die or whatever the case might be. And unlike a professional machine where you can just pop in there and replace that part, on the consumer level machines, not only are the parts not available, they're totally inaccessible. Right? It's like taking your iPhone apart. Like it's not going to happen for a normal dude. And I think that's a key difference between like consumer level stuff and professional level stuff. So I think it's a mixed bag. So with all that said, I don't know. I don't have a super
excellent. I would say out of the resin machines, I have a bunch of formlabs machines. Those are semi professional machines that they've done really well for me.
Yeah, those are good machines.
They've been a good overall machine.
I think at the top of the pack, you definitely have formlabs. You got Ultimaker. You got MakerBot. I mean, there's a handful. You got Prusa. Yeah, it's a handful of these different brands that are well known and trusted out there. And I think each have their own trade-offs and idiosyncrasies. They're all pretty good.
Yeah. So kind of like summarizing that, I'm going to try to summarize that.
Okay, let me hear it.
If you're just starting out and you're looking for a machine that's going to give you a little bit more reliability then less, then a prusa is probably a good way to go. There are different price point prusa machines as well.
They also have kits.
Right,
It's like
right.
a whole thing. Yeah.
Yeah.
Like I said, I don't play in that universe very much. I'm
Yeah.
usually people usually work with me when they're done with prusa and they're ready to go to that next step. That's when they work with us usually.
So what about that next step then? Where is that? What are we saying, man? We got to give them something.
Yeah. No, I mean, for us, we are a little bit biased, right? So we've surveyed the market, right? And we felt that like most of the product available in North America is kind of not up to snuff, right?
Yeah.
So in North America, we identified that the MakerBot printers are pretty high quality, the new version of them. They just merged with Ultimaker, right? So Ultimaker, MakerBot.
Wait, I mean, what actually happened there? The Ultimaker merged into...
That's such a crazy thing, yeah. I mean, nobody knows the exact details, but from what I can tell, Ultimaker effectively acquired the consumer level or beginning industrial level 3D printing component of Stratasys, which was
really
that's what I see happening.
I would see it happening the other way. Really.
That's what everybody would see, but what you find is that actually Stratasys invested money into that entity, which is bizarre. And on top of that, they kept the name Ultimaker, not MakerBot. It's not like Ultibot or something, which they could have easily done.
Yeah.
It's now Ulti with a capital M Maker. It's the same name.
Clever, very clever.
Yeah, I think at that level, those machines are good.
Yeah.
We tend to work with a brand called Innovatic, which is based out of Germany. Most of our products come from Europe. So Innovatic, that's actually the machine that you got from us years ago, is a German rep wrap.
Yeah, I love that machine, by the way.
So
I will say that this guy here helped me make so much money, and that's what Al does well. He helps you find the best solution for your challenges that you're having, and to at a budget that can make sense for you. So I mean, it's been an amazing partner to me, and I can't wait. Listen, we're gonna close this one up though. We're gonna come back and do a part 2 right after a few minutes. So thank you guys for checking out this podcast. We're gonna come right back after a couple brief messages. No, we'll come right back. So good stuff.